Dear students, a study is a continuous process. We have studied about speed. Now we will learn what is velocity. And I have a good suggestion for you that as you are going to learn every concept, you also start solving problems on based on those concepts. Then you will only feel that what the concept is mean by. आपको प्रतिदिन कम से कम 10 से 15 न्यूमेरिकल्स करने चाहिए. जब आप न्यूमेरिकल्स करेंगे तभी आप किसी भी कंसेप्ट को अच्छे तरीके से समझ सकते हैं. कोई भी एक किताब ले लीजिए, उस किताब के न्यूमेरिकल्स करिए. मैं भी कुछ न्यूमेरिकल्स आपको देता रहता हूँ, उसको भी आप करते रहिए. और किसी भी प्रकार का यदि कोई भी डिफिकल्टी होती है, कहीं आपको समझ में दिक्कत होता है, तो प्लीज राइट टू मी. I will come back to you to explain those things again. So let us see what is velocity. Earlier we have seen a speed. What was the speed? A speed was the rate of the change of distance. किसी भी ऑब्जेक्ट की कितनी तेज गति है उसको मापने के लिए स्पीड हम लोग नाम स्पीड का कंसेप्ट आया था. बट वेलोसिटी इज समथिंग डिफरेंट. Velocity is related to displacement. With time, the displacement of an object changes. So, what is the rate of those changes? That rate is defined by velocity. So, first we will consider average velocity. What is average velocity? So, let us consider the motion of an object on a straight line. So, this is x-axis. This is our 0 point, then 1, 2, 3, and this is -1, -2, -3. So, the position of any object could be anywhere. Let us say that at time t1, this x1 is equal to 1, at time t is equal to x2 is equal to 2. So, what is the displacement between time t1 and t2? So, displacement is between time t1 to कितना है? The final position is x2, initial position is x1, that is x2 minus x1. Why we are not writing direction here? Because this positive meaning of 1, if 1 that means we are in the positive direction, 2 that means we are in the positive direction, -1 that means we are in the negative direction, -2 that means we are in the negative direction. So this sign plus or minus will give the direction, the sense of direction when an object is moving on a single line. So that's why there is no need to write from x1 to x2, yeah, positive direction x-axis. This sign will itself give the direction, the sense of direction. So displacement between point t1 to time interval t1 to t2 is x2 minus x1. So average velocity will be what will be displacement between time interval t1 t2. Displacement between time interval t1 to t2, and this is time interval. What will be time interval? That will be t2 minus t1. So this can be written as x2 minus x1 upon t2 minus t1. So now this can be written in another way also. Then what is this x2? X2 is the final position in this time interval t1 t2. And what is x1? X1 is the initial position in this time interval t1 to t2. So this can be written as final position minus initial position on what is this? This is time interval t1. So this is average velocity. What is the meaning of this average velocity? That what is the displacement between t2 to t2 minus t1 interval? So this will give an average figure of the velocity. But the velocity can be different at different points. So let us consider that as a velocity in the next after some time. Let us see the nature of this average velocity. See, this average velocity is related to displacement. Now displacement has some direction. This displacement has some direction. So this average velocity will also have some direction. If this x2 minus x1 is coming positive, in that condition, this average velocity will be positive because time interval will always be positive. Time interval cannot be negative because we are always taking t2 minus t1. We cannot write t1 minus t2. t1 minus t2 doesn't mean t1 because time is always progresses in single direction. It is always moving up. So time interval is always positive. So the sign of average velocity depends upon the sign of displacement between those two time intervals. Okay. So if displacement is coming positive, average velocity will come positive. What is the meaning of this average velocity becoming positive? Average velocity means the object is moving in the positive x direction. When the average velocity is coming positive, that means the object is moving in the positive x direction. And when the average velocity is, when displacement is negative, average velocity will come negative, and then we say that the object is moving in the negative x directions. Negative x directions. See, here we have taken x2 minus x1. Here we have taken displacement x2 minus x1. Now we take the value of x2 minus x1. Here, so interval this average velocity will be x2 minus x1, t2 minus t1. So now let us consider that t1 is something like 1 second, t2 is 2 seconds. Okay, and this is in meter. Okay, so x2 minus x1, that means 2 minus 1 meter upon t2 minus t1 is 2 minus 1 second, that means 1 meter per second. This positive direction is giving a sense that the object is moving in the positive x direction, and of course we are moving in the positive x direction because we are moving from at point 1 to point 2. Okay, but let us consider that at t3 we again come back at this position. So we went here and now we came back here. Okay, so in the time interval, this is in the time interval t1, what will be average velocity in the time interval t2 to t3? So what will be the position at point at time t3, that is x3? What is the position at time t2, that is x2? So, and this will be t3 minus t2. Now x3 is 1, x2 is 2. So, and this will be 3 minus 2. So this will be minus 1 upon 1, that is minus 1 meter per second. So see here, in the time interval t1 to t2, we are moving in the positive x directions. So this average velocity is also coming 1 meter per second. In the time interval t2 to t3, we are the displacement is negative, so this average velocity also becoming negative. That means we are moving in the negative directions. We are not in the negative zone, but we are moving in the negative directions. That's why our average velocity comes negative. So V average, this is a vector quantity, so let us give a vector sign, will be initial final position, that is R2 minus R1 upon T2 minus T1. When we will work in the plane, then we have to take two graphs, like this is y and x axis, and then any point in this plane will be expressed by two things like x or y. Now the origin will be this 0 to 0. So any straight line that is adding from this origin to the point, and this will be the vector. So this point O to P, this OP vector, will call the position vector of point P. This OP is position vector of point P. What is this? Position vector of point P. This is OP, and this can be written like R length. So any point you take, and you just draw a straight line from origin to that point, that will give the position vector of that point. Now, what is the displacement between point P to Q? Displacement is a straight line drawn between these 2 points. So this PQ will be the displacement. Here PQ will be the displacement. Now how can you write this PQ in terms of position vectors? So we are knowing the principle of addition of vectors, and from there we can say that OP vector plus PQ vector, see, this is the tail, this is head, this is tail, this is head. So we have two vectors, we want to add these two vectors. In this condition, we have to draw a line starting from the tail of the first vector and ending with the head of the second vector. So here we are seeing that this is our first vector, so tail is O. This is our second vector, so tail is Q. So this OP plus PQ barabar will be OQ. Now see, OP is R1, PQ is PQ, and OQ is R2. So PQ will be R2 minus R1. So this will be the displacement. PQ will be the displacement. And if we are knowing the position vector of P and Q, then we have to simply subtract from position vector of Q to the position vector of P, and that will give the displacement. In the same way, if our origin is this O, then what will be the position vector of any point P? So we have to simply add from origin to this point P. So this will give the position vector of point P. Similarly, we are taking another point Q, then its position vector will be this R2. What will be the displacement between this P and Q? That will be simply R2 minus R1. And time interval is T2 minus T1. So average velocity will be R2 minus R1. But the simplest way to understand the fact is that final position, when we are saying that position, that simply implies this position vector. So final position minus initial position upon time interval. That is displacement by time interval. Okay, so when we want to calculate what is the velocity between average velocity between 2 points, between 2 time intervals, then just like displacement, we have to know what is the final position at time t2 and what is the initial position. Then we have to get the displacement by subtracting final position minus initial position and dividing by time interval. That will give the average velocity. But average velocity will not tell what will be the velocity at some particular point of time. Like if an object, we have moved from point P to Q, so our velocity is coming positive, and for the time being we have again returned and reached this point R. So for again our velocity, what will be velocity between P and R? That will come positive because displacement is positive. But for some sort of time we have moved in the negative direction, and that is being not covered between by this average velocity. So somehow we have to reduce this interval, and we have to reduce the interval to catch this motion of the object. So we have to take the interval between R and Q, then only we can come to know that object also moved in the negative direction. So this can be written as V average can be written as del R upon del T. So this is the change in position by time interval. So this time interval can be reduced to a smaller and a smaller time interval. And अगर इसको हमने del t को 0 के बराबर ले लिया, del t को हमने बहुत छोटा ले लिया 0.0000 समथिंग सेकेंड, देन ये जो वेलोसिटी होगा वह इंस्टेंटेनियस वेलोसिटी हो जाएगा, और इसको सिंपल टर्म हम लोग वेलोसिटी भी बोलते हैं. तो दिस वेलोसिटी का मतलब क्या है, वे एवरेज ही रहेगा, लेकिन ये जो टाइम इंटरवल डेल्टी दैट विल मूव टू 0, एंड सो वी कैन राइट दिस लाइक लिमिट del t टेंड्स टू 0 del r by del t. So this can be written from the definition of differentiation, that is dr. So this is nothing but rate of change of displacement. So this velocity gives the rate of change of velocity, position. Rate of change of position is called velocity, at a particular time t. So this average velocity gives the sense of velocity between the time interval t2 minus t1, but this velocity v will give you the velocity at particular time t. So if del t is tending to 0, then time t will be some time t, any particular time t. So at particular time t, velocity is given by this formula dr by dt, that is rate of change of position. Okay, so velocity is rate of change of velocity. Again, velocity is also a vector quantity. Now this velocity and the speed we have calculated, that is s, that means dx by dt, or here we can write ds by dt, and this is our speed. So you know that at very small interval of time, this dr will be equal to ds. This will become kind of a scalar. So the magnitude of this velocity will give the speed at that point in t. Magnitude of this velocity will give the also give the speed of the at point time t. Okay, so we have to understand these two concepts. We will solve many problems and then we'll elaborate these things in detail. So we have come to know that velocity of an object also can change with time. So let us consider that at point t1, the velocity of an object is v1, and at point time t2, the velocity of the object is v2. Then what is the thing? What is the physical quantity that captures this change in velocity? And that will be captured by the average acceleration. So average acceleration is defined as change in velocity. That means final velocity minus initial velocity by time interval t2 minus t1. So for calculating average acceleration, we have to know what is the final velocity and what is the initial velocity, and we have to divide the difference of final velocity and initial velocity by time interval. Now the final velocity is more than initial velocity, then average acceleration will become positive. If final velocity is less than initial velocity, then average acceleration will become negative. So the average acceleration also depends upon the directions and magnitude of the velocity. So this average acceleration is also a vector quantity. So average acceleration is also a vector quantity. Velocity is a vector quantity. So for a vector quantity, change means two things. If the magnitude of a vector changes, then also we are saying that vector has been changed. And if the direction also changes, then also we are saying that there is some change. So in the case of the change of velocity, if the magnitude of velocity is not changing but direction is changing, then also there will be some acceleration. There's many such things, like if you are moving on a circle with constant speed but direction is changing always, so there is some acceleration and we are feeling some kind of force. So either magnitude will change, then there will be some acceleration, or either direction will change, then also will be there some acceleration, or if magnitude and direction both changes, then also will be there some acceleration. Now, like the velocity and speed, what will be the acceleration at particular point of time? So we can write this also like change in velocity by time interval. So when del t becomes almost zero, then we will get acceleration at time t. So acceleration at time t will be limit del t tending to 0 del v by del t, that is rate of change of velocity at particular time t. So average acceleration is then acceleration. This acceleration is also called instantaneous acceleration. What is called instantaneous acceleration? So today we have come to know about two concepts: what is velocity, what is acceleration. In the both concepts, we come to know the difference between what is average velocity and what is velocity at a particular time t. And similarly, what is average acceleration and what is acceleration at a particular time t. Now we will move ahead and we learn about the relation between acceleration, time, position, and we will come to know about the three important formula which will always be with you throughout the journey of this physics. So just keep working hard.